Hi. Today's lecture we're going to discuss remote monitoring. One of the most important applications for the DSTS system is to monitor a structure such as a dam or an oil pipeline for any signs of strain or temperature changes that signal a danger or a problem of some sort. You want to be able to use the system to continuously monitor a structure 24 hours a day, 7 days a week, and let you know when something unusual is occurring. You want this to all happen automatically so it can all occur without you being present. Such a feature is critical if you are to have continuous monitoring around the clock of any sort of critical structure. In this lecture we're going to show you how to set up the unit to make continuous measurements. We're going to show you how to use the computer to send alarms. We're going to show you how to receive those alarms and understand what they say. And we're going to show you how you can remotely access the computer from anywhere in the world so that you can identify what's going on using third-party software. We think this will be very informative to you, and we hope that you enjoy our demonstration. So for our demonstration, we have our DSTS system here connected up to 2 spools of fiber, and in between we have a section of fiber. We're going to set up the unit for continuous measurements, and then we're going to heat up this section off the fiber using my hand and have that trigger an alarm on the system. So the first step is to actually set up the software to actually identify and set alarms. So to do that, we access the button called Alarms and Reporting, which brings up this menu display for setting alarms for either changes in temperature or changes in strain. And we have a number of features and options for these alarms. Now we have a variety of settings for generating alarms in either strain or in temperature. We're going to be generating an alarm in temperature, so we're going to enable the temperature button. Once you have the options set up on your system, you can now set up how you want the computer to send messages to the people for these alarms. So to actually send an email message, the computer has to have access to some sort of email server. In order to set this up, you may have to get help from your local IT expert within your own company. For example, you may just want to have one person getting emails for minor alarms, but if a major alarm or a critical alarm occurs, you may want the email to go out to multiple people, identifying that we have an urgent situation that needs to be dealt with. Once you have it set up the way you want, you select OK, and then the system is ready to send emails. The one last thing you can set up on the system is what else the computer needs to do when an alarm occurs. We have 3 check boxes. One to say to log the alarm record. That'll save the actual alarm details into a text file that you can access. Next is send the alarm message out by email. And third, to save the processed data that caused the alarm, to allow you to bring up a screenshot of the alarm data on the system. Now that we have the alarm set up, let's now go and set the unit up to make continuous measurements. So we click on the measurement button. We've already taken a baseline measurement in the same fashion that we've used in previous videos. The measurement process is all the same. The only exception is you want to click on, first click on the strain temperature button, and then you want to click on the button that says continuously scan. And on here you set a time frame over which to make those scans. So right now we have it set up continuous scan per every 3 minutes. So right now, every 3 minutes, the computer will take a new scan off the fiber. So depending on how often you want to take a reading, you can increase or decrease the number of minutes between scans. Once you have that set up, and you identified it as being strained, you're ready now to take a reading. Notice on the screen, it is actually showing those alarm levels since we've set it up. The red bands identifying the critical alarms, the yellow bands identifying major alarms, and the blue bands identifying minor alarms. In our test here, we're going to heat up this section of the fiber using my hand, which should generate a temperature increase between 5 and 10 degrees. We've set up the instrument so that 5 degrees change will generate a minor alarm, whereas a 10 degree change will generate a major alarm, and a 20 degree change will generate a critical alarm. So the temperature from my hand should be sufficient to trigger an alarm, causing the computer to send an email to a neighboring computer. We have a computer set up over here ready to receive emails from our DSTS unit. So let's start off, and we start the system making measurements. The process is exactly the same as it was before. It just starts recording. So we've got our initial reading, and we can see that the temperature along the fiber is staying well within our 3 alarm bands for minor, major, and critical problems. So now I will place my hand onto the fiber in order to heat the temperature up, so when it makes its next measurement, it will generate an alarm. So the 3 minutes have gone by, and as you can see, the computer is now taking another reading. This time, with my hand on it, heating the fiber, this will generate an alarm. Alright, and it's finished making the analysis, and as you can see on the screen here, at this point here, we have a clear spike at the point 7140.74 meters with a reading of 6.22. Let's see if we've gotten an alarm sent to the other computer. And if we look, we have an alarm from this alarm email message telling us that there's been a minor high temperature alarm reported at 7139.92 meters, ending at 7141.56 meters, with a peak of 6.43 degrees Celsius. So, we now have an example of an alarm sent off by the system. So if you look at the main screen here, there's a flashing message here warning you that an alarm has occurred. So if an alarm occurs in the middle of the night and you come back the next day and haven't checked your emails, you would see this note here, this flashing message here warning you that an alarm took place overnight. Now let's say you want to see some more details about that alarm, what it was and when they occurred. Well, under Alarm and Reporting, you can click on the button that says Get Temperature Alarm Report, since what we're monitoring is temperature. And that'll bring open a text file, which we will bring up in Excel, giving us the details about the alarm. So it tells us what type of measurement process was being done during the alarm, when the alarm occurred, what channel the alarm occurred on, what type of alarm, the point where it started, the point where it ended, and the temperature value that caused the alarm. If you have like multiple alarms in the middle of the night, for example, you would see them on this log file, one after the other after the other. Now, if you want to see that alarm in more detail, then going back to the software here, if we go to Measurement again, we can hit Load, click on Process Data, hit OK, and we can bring up the latest alarm that occurred here. And if we bring it up, it overlays it on our current screen as this red file. We can zoom in into the area of interest. And you can actually see that temperature plot that generated the alarm and compare it with what's on the screen at the current time. So you can actually see the difference between what generated the alarm at that time and what currently is happening on your screen. So that's looking at the alarm in detail on the existing computer. But suppose you're not at this computer. Suppose you're at home or away at some other location and you need to check what was showing up as the alarm on the system. Well, as this is a Windows-based computer and as it is accessible through a network, you can remotely access the computer using third-party software and thus look at the results being shown on the system. There are many different types of software out there for accessing a computer remotely to see what's happening and to take control of it. Your IT department will probably have some preferred control system for doing this. We're going to use a software called TeamViewer. It is available as a freeware product for academic use or for personal use. And it will work fairly well for our demonstration here. So in order to remotely access the DSTS computer, you need the software installed on both it and on the computer that needs to do the remote access. You need to assign a name and a password to the DSTS computer, and you have to initialize the software to allow it to permit remote control. You may need your IT department to adjust your network settings to allow the software to work past the network firewall. So please work closely with your IT professionals when setting up the unit for remote access. To access the DSTS system from a remote computer, you set up that other computer to the panel stating Control Remote Computer, and once there you hit the button saying Connect to Partner. It'll ask for a password, and if you enter the correct password, you'll get a full screen display showing you what is currently on the existing DSTS unit. And from here, you can take all the actions that you can from the computer itself. You may go to your alarms. You can bring up the temperature alarm report, pop it up on the screen, and look at your displays. Similarly, you may go back to the measurement screen and load the data from the alarm report, and everything looks as if you're working from the DSTS instrument itself, allowing you complete access to the instrument and thus allowing you to observe the alarm remotely. So in a nutshell, using third-party software like TeamViewer combined with the messaging system built into the DSTS software, you can receive alarms from the system remotely and control the system to see what is going on from anywhere around the world. I hope you find this demonstration useful. If you have further questions, please contact us at Oz Optics. Thank you.